Hello everybody, welcome to the video. Today we're going to be going over how to simplify radicals, and remember radicals are expressions with square roots. So the square root of x, that's going to be a radical, okay? So in order to simplify radicals, you should be familiar with perfect squares. So whenever you take an integer like 1, 2, 3, 4, just a regular whole number, and multiply it by itself, then you get perfect squares. So all these numbers in the diagonal of the multiplication chart are going to be perfect squares. 1, 4, 9, so on and so forth. The strategy for simplifying radicals is that you have to look for the highest perfect square that divides the number inside the square root. We call that number the radicand. Then you factor the radicand. Then you take the square root of the perfect square and leave the other number inside the radical. Okay, so those are the steps. That is the strategy. So we're going to go over two examples of how to do that today. So we'll begin with this one, the square root of 18. So remember, to simplify radicals, we have to look for the highest perfect square that goes into the radicand, 18. So let's list the perfect squares right here. Notice I did not list 1 because 1 goes into every number. So we're going to start with 4. 4 does not go into 18, but 9 does, right? Because 18 is 9 times 2. So we're going to rewrite the square root of 18 as the square root of 9 times 2. Then we can rewrite that as the square root of 9 times the square root of 2. And then the square root of 9 would just be 3. And so the solution would be 3 times root 2. So that's going to be our solution. The square root of 18 reduces to 3 times root 2. Okay, so let's go over one more example here. We have the square root of 32, and again, we're looking for the highest perfect square, one of these numbers, that goes into 32. Well, 4 goes into 32. It's not the only perfect square that goes into 32, so I'm actually going to do this problem two different ways, but let's just work with the number 4 first. So we have the square root of 32. 32 goes into 4, and 32 is just going to be 4 times 8. So we rewrite 32, we factor it to 4 times 8. And the square root of 4 is just 2, so we have 2 times root 8. Now this radical right here can be further reduced because 8 is actually going to be 4 times 2, right? So we can reduce this a little bit more. We can change 8 to 4 times 2. And then we take the square root of this 4 right here, that red 4, to get 2, and we put it outside the radical there. Then we're going to multiply these two numbers. We have 2 times 2, which gives us 4. So the solution would be 4 root 2. Okay, so that's going to be our solution. Now that was more steps than the last one, but we didn't choose the highest perfect square that goes into the radicand. So this is an acceptable way of doing it. I want to show you a kind of a faster way of getting there though. Okay, so this is going to be a second way of doing it. So it is true that 4 goes into 32, but there is a higher perfect square that does. It's not 9, it's 16. So 32 is just going to be 16 times 2. So if you do it this way, you'll realize that the square root of 16 is just going to be 4, which leaves you with the square root of 2 in the square root. And notice it's the same answer that we got right here. So we can box it up, and that is our solution, okay? So if you don't choose the highest perfect square that goes into the radicand, you have to do a little bit more work. So try to look for the highest of these numbers that goes into the radicand.